Okay. Question number 5, 10.3. Show that each of the given vector is a unit vector. A 1 by 7, 2i plus 3j plus 6k, and vector B is this is 6k. Vector B is 1 by 3, 3i, this, and vector C. Also show that they are mutually perpendicular to each other. They are unit vector means we have to find their magnitudes, and their magnitude should come 1. Okay. So under root magnitude of A will be equal to 2 by 7 whole square plus 3 by 7 whole square plus 6 by 7 whole square. Four by 49 plus 9 by 49 plus 36 by 49. So 36 plus 9 plus 449. So this will become 49 by 49, that is equal to 1. So it is a unit vector. Similarly, find the magnitude of vector B to show that it is a unit vector. Unit vector means the vector which has magnitude 1. So find the magnitude of this also. This is I think 1 by 7. Yes. This is 1, not 1 by 3. This is 1 by 7. Okay, so 1 by 7, 3i minus 6j. So 3 by 7 whole square plus minus 6 by 7 whole square plus 2 by 7 whole square. So this will be equal to 3 by 7 is 9 by 49 plus 6 is 36, 36 by 49 plus 4 by 49. So again you are getting 49 by 49, that is equal to 1. So it is a unit vector. Third, vector C, also we have to show that it is a unit vector. To find its magnitude, it should be equal to 1. Then it will be a unit vector. So 6 by 7 whole square plus 2 by 7 whole square plus minus 3 by 7 whole square. Again 6 is 36 by 49 plus 2 to the 4 by 49 plus 3 is 9 by 49. So 49 by 49, again 49 by 49 is equal to 1. So this proves that A, B, C are unit vectors. Okay, they are unit vectors. Number 1 proved. Second part, show that they are mutually perpendicular to each other. So we will find A dot B. You know that if A is perpendicular to B, then this implies that A dot B is equal to 0. Then they are perpendicular. So first we will find A dot B, then B dot C, then C dot A. So find A dot B. So A dot B, so A is 2 by 7i plus 3 by 7j plus 6 by 7k. Value of A dot product with B. B is 3 by 7 my 3 by 7 I minus 6 by 7 j cap plus 2 by 7 k cap. So when we are multiplying the vectors which are resolved in their component with dot product, so their only coefficients will be multiplied, means 2 by 7 into 3 by 7, I and I will multiply, plus 3 by plus 3 by 7 3 by 7 into minus 6 by 7 plus 6 by 7 into 2 by 7. So this will become 0 because 3 to the 6. So 6 by 7 and 6 to the 12. 6 by 7 plus 12 by 7 and minus 6 to the 12. 6 3 the 18. 6 3 the 18 by 7. So 6 plus 12, 18 minus 18. So this will be equal to 0. Now find B dot. So this shows A is perpendicular to B. Now B dot C. Either you find A, B dot C or C dot B because it is commutative. Huh? So B dot C. So B is 3 by 7 I cap minus 6 by 7 J cap plus 2 by 7 K cap dot C, and C is 6 by 7 I cap plus 2 by 7 J cap minus 3 by 7 K cap. So multiply 3 by 7 into 6 by 7, then minus 6 by 7 with 2 by 7 plus 2 by 7 with minus 3 by 7. So 3 6 are 18 by 7 minus 6 2 are 12 by 7 minus 3 2 are 6 by 7. So 18 minus 18, 0 by 7, that is equal to 0. Then C dot A. C dot A. C. Vector C is 6 by 7. 6 by 7 I cap plus 2 by 7 J cap minus 3 by 7 K cap. C dot A. C dot A. A is 2 by 7 I cap plus 3 by 7 J cap plus 6 by 7 K cap. So multiply 6 by 7 into 2 by 7 plus 2 by 7 into 3 by 7 minus 3 by 7 into 6 by 7. So again 6 2 are 12, 12 by 7 plus 3 2 are 6 by 7 minus 18 by 7 is equal to 0. So which shows that A, B, C are mutually perpendicular to each other. A, B, C are mutually perpendicular to each other. equally perpendicular to each other. So question number 6, we have to find the magnitude of A and magnitude of B. If A plus B vector dot A minus B is equal to 8 and magnitude of A is equal to 8 times magnitude of B. So we have given A vector plus vector B dot vector A minus vector B is equal to 8 because their product dot product is a scalar product. So right hand side you will get a scalar, and this will be frequently used here. A dot A. A dot A is equal to magnitude of A square. Because the angle will be 0. So cos 0 degree is equal to 1. So it will be equal to magnitude only. Now multiply. First you have to multiply this. So A will multiply with A. So you get A dot A. Then A multiply with B. A dot B. Then B multiply with A. So B dot A. Then B with B plus minus minus B dot B is equal to 8. Now, as I told you, A dot A is equal to the square of its magnitude. It will convert into magnitude. And A dot B and B dot A both are same. So, this both will be cancelled. We get minus B dot B is also equal to the square of its magnitude. Understood how we are getting this? A dot A is equal to A square. If you have a problem, you can ask. Now also we have given the value of A as also A is equal to 8 times magnitude of A is equal to 8 times the magnitude of B. This is our given condition. So if this is suppose equation number 1. So this put in equation number 1. Equation number 1, A magnitude of A can be written as 8 times the magnitude of B's whole square minus magnitude of B square is equal to 8. Okay, so 8 is the 64 magnitude of B square minus magnitude of B square is equal to 8. 64 minus 1, 63 magnitude of B square is equal to 8. Therefore, magnitude of B square will be equal to 8 by 63, or magnitude of B will be equal to under root 8 by 63. So this we got the magnitude of B. Now we can simplify if possible. We can simplify this 63 can be 8 can be written as 4 to the 8. So 2 root 2 will be left in the numerator and denominator will become 7 9 the 63. So 3 root 7. So 2 by 3 root 2 by 7. 2 by 3 root 2 by 7 we can write. So this is the magnitude of B. Also we have to find the magnitude of A, and the magnitude of A is equal to, given us 8 times the magnitude of B. Just substitute this value of magnitude of B is 2 by 3 under root 2 by 7. This value just substitute here. We get 8 into 2 by 3 under the root 2 by 7 multiply 8 to the 16 by 3 under root 2 by 7. So we got both the values, magnitude of A and magnitude of B. Question number 7. Question number 7. So evaluate this value. Question number 7. It is the dot product. So 3 vector A minus 5 times vector B dot 2 times vector A plus 7 times vector B. So 3 to the 6 A dot A. 3 sevens are 21. This will multiply with this. Then this will multiply with this. So 3 sevens are 21. A dot B. Then minus 5 to the 10. B dot A. Then minus 5 sevens are 35. B dot B. So A dot A is equal to square of its magnitude, A square, and 21 minus 10. A dot B and B dot A are same. 21 minus 7, so 11 times A dot B minus 35 times square of the magnitude of vector B. So what else we can solve? No, we have not given any value. We cannot solve more than this. So this is the answer. Question number 10. Question number 8, exercise 10.3. Find the magnitude of the two vectors A and B having the same. Find the magnitude having the same magnitudes. Means we have given their magnitudes equal and the angle between them is 60 degrees and their scalar product is this one. So what we have to find, we have to, their magnitudes are equal. It is given their magnitude of A will be equal to magnitude of B. What else we have given? Magnitudes are equal. Angle between them is 60 degrees. So theta is equal to 60 degree. And their scalar product means A dot B is equal to 1 by 2. Okay. So find their magnitudes. So you know that cos theta is equal to A dot B upon magnitude of A into magnitude of B. Just substitute the values. Cos 60 degree is equal to A dot B is 1 by 2 divided by magnitude of A and B both are same. So we can write magnitude of A into magnitude of A because they are same. So magnitude of A square and cos 60 degree is again 1 by 2, and this 1 by 2 you can, and this cancel 1 by 2 will give you 1. So or you can write magnitude of A square is equal to 1. So therefore the magnitude of A is equal to 1, and also because the magnitudes are same, also the magnitude of B will be equal to 1. Okay, so that was asked to find the magnitudes of A and B. One condition given, their magnitudes are same. Angle between them means if this is vector A, vector B, the angle between them is theta. This is vector A, this is vector B. Okay, then you can use this formula and substitute the values because A dot B is also given 1 by 2. Substitute 1 by 2 and cos theta, and here A can be replace B can be replaced by A or A can be replaced by B. Anything you can replace because this is the same. They are having the same magnitude. It is given here. These are so then replace these two and then substituting and find the value. Question number 9, 10.3. Find magnitude of vector x if A is a unit vector. A is a unit vector means its magnitude is equal to 1 because A is a unit vector given us. Then find the magnitude of x. So this is the given condition. So multiply x minus vector A dot x plus vector x plus vector A is equal to 12. Multiply inside or to x dot x dot x plus x dot A minus A dot x minus magnitude of A dot A is equal to 12, and these two will cancel. We get magnitude of x square minus magnitude of vector A square is equal to 12, but value of A is 1. So magnitude of x square minus 1 is equal to 12. So magnitude of x square is equal to 12 plus 1, 13. Therefore, magnitude of x is equal to under root 13. So question number 10, 10.3, if A vector, B vector, C vector are given and A plus lambda B vector is perpendicular to vector C. And if we know that if vector A is perpendicular to vector B, this means we can write A dot B is equal to 0. So here similarly here these two are perpendicular vectors, so we can write vector A plus lambda times vector B dot vector C is equal to 0. Now you can substitute the values of the vectors. Vector A is 2i plus 2j plus 3k, vector A, okay, plus lambda times vector B. Vector B is minus I plus 2j plus k dot vector C. Vector C is 3i plus j plus 0k. For your convenience, you can write 0k is equal to 0. First of all, you have to solve this bracket 2i plus lambda minus I. So if you will take I common, so this will become 2 minus lambda I cap plus 2j means 2 plus 2 times lambda j cap plus 3 plus lambda k. So ijk has been taken common here. Okay. Now dot product of this with the vector 3i plus j plus 0k cap is equal to 0. Right hand side is 0 because it is a dot product. Now multiply. When you multiply, you know that all the coefficients, corresponding coefficients of ijk will be multiplied, and with the addition, so 2 minus lambda into 3 plus 2 plus 2 lambda into 1 plus 3 plus lambda into 0, that will become 0. No need to write also. So this multiply 3 2s are 6 minus 3 times lambda plus 2 plus 2 lambda is equal to 0. 6 plus 2 8 minus lambda is equal to 0. Therefore, lambda is equal to 8. The question was to find lambda. So we got the value of lambda as 8. Question number 10.3. Exercise 10.3, question number 11. Show that these two vectors are perpendicular, where both are non-zero vectors. Otherwise, we cannot do it. This is the condition. There must be non-zero. So, means we have to show that this vector is perpendicular to this vector. That means we have to show their product should be equal to 0. So first vector is magnitude of A vector B plus magnitude of B vector A dot magnitude of A vector B minus magnitude of vector B vector A. This dot product should come 0. So first we will multiply this with this one. So magnitude and magnitude will multiply magnitude of A square, then B dot B. B dot B. First we should write B dot B. Later on in the next step you can write square of the magnitude. Then multiply with this one. So minus magnitude of A into magnitude of B, and this B will multiply with A. So B dot A, vector B dot vector A. Okay. Now multiply this with this one. So we will get magnitude of vector B into magnitude of vector A into A dot B. Then this multiply with this one, plus minus minus magnitude of B into magnitude of B, B square, and magnitude vector A dot vector A. Okay, so these two are same values. It will cancel, and now magnitude of A square and B dot B, you know that B dot B is magnitude of B square. Similarly, this is magnitude of B square, and A dot A is what? Magnitude of A square. So both are same. Magnitudes can be written 5 into 2, 2 into 5 are the same thing. These are the magnitudes, these are the values which can be written in any order, but they are same. So therefore we get 0, which shows that vector magnitude of A vector B plus magnitude of B vector A is perpendicular to magnitude of A vector B minus magnitude of B vector A. You got it? So the question is, if A dot A is equal to 0, left side is a dot product, so right hand side we can write 0. It is given already, and A dot B is equal to 0. So just you have to take care of it. Left hand side dot product, so right hand side will be a scalar quantity. If it is a vector, so right hand side you have to write vector 0. For example, we have done cross product also. That's why I'm telling you A cross B. So you cannot write A cross B is equal to 0. You have to write vector 0. Okay. So now What can you conclude? A dot A is equal to 0. If A dot A is equal to 0 and A dot B is equal to 0. As we have given, if A dot A is equal to 0. So from this, we get A dot A is equal to 0, which implies that A magnitude of A square is equal to 0, which shows that magnitude of A is equal to 0. When the magnitude of A is equal to 0, that means A is a 0 vector. What is 0 vector? Which has magnitude 0. So A is a 0 vector. We got the conclusion that A is a 0 vector about A. But they are asking, what can you conclude about vector B? Now, as A is 0, therefore, since A is a 0 vector, therefore A dot any vector, if you will take any vector, because A is a 0 vector, this will give you 0. So that means B is independent of me. We cannot say anything about B. So that means that nothing can be concluded about B. B can be any vector. So this shows that B can be any vector. Because A is already 0, when you multiply with 0 with any vector, you will get 0. So that means B can be taken any vector. Question number 13 of 13.3 exercise. If A, B, C are unit vectors. A, B, C are unit vectors. That means their magnitudes vector A, magnitude of vector A, magnitude of vector A, because they are unit vectors, so magnitude of vector A is 1, magnitude of vector B or magnitude of vector C all equal to 1. And we have to find A dot B, B dot C, C dot A, and their sum is equal to 0. Okay, so we can write, because this is equal to 0, so both sides we can multiply with A plus B magnitude of vector 0 vector is 0, yes, magnitude is 0, yes, sure. Magnitude of 0 vector is 0, yes, correct. So A, they are equal to 0 vectors, so when we multiply, we can multiply this. See what we have given, just see this logic. We have given this equal to vector 0. Okay, now we can multiply both sides by A plus vector B plus vector C dot A plus vector B plus vector C. Both sides are multiplied by dot product of A plus B plus C. But right hand side, as it is a 0 vector, so this will be 0. But now this 0, yes, now this is becoming scalar quantity, because left hand side we are writing dot product. So when you multiply with any vector with 0, this will become 0 magnitude, not the vector. Now you can solve it. So A dot A, first multiply A with all values, A dot A plus A dot B plus A dot C. Okay. Now multiply B with B dot A plus B dot B plus B dot C. Then multiply C dot A, C dot A plus plus C dot B plus C dot C is equal to 0. They are unit vectors. Magnitude of A dot A means magnitude of A square plus A dot B, B dot A. This is B dot A, okay, and this is A dot B. So we can write 2 times A dot B because dot product is commutative. Similarly, this A dot C, and here you have C dot A and A dot C will become 2 times C dot A. Okay, then B dot B, this B dot B will become magnitude of B square. Then this B dot C plus C dot B will be equal to 2 times B dot C is equal to 0. And where is C dot C? Yes, that is left. C dot C plus C dot C is equal to magnitude of C square is equal to 0. Now these all magnitudes equal to 1. So here we will put 1 plus 2 times 2 is taken out, A dot B plus B dot C plus C dot A plus this magnitude of B square is 1, C square is 1 is equal to 0, 1 plus 1 plus 1 is equal to 3. So 2 times A dot B plus B dot C plus C dot A is equal to minus 3. Therefore, the value of A, we got the value of A dot B plus B dot C plus C dot A is equal to minus 3 by 2. Minus 3 by 2. So you can see that this is A dot B, scalar quantity, scalar quantity, scalar quantity. Some of the scalar quantities is scalar quantity. So always when you are writing both the sides, just check. Both sides should be vector quantities or both sides should be scalar quantities. It is very important to write. Yes. If one of them is 0, then their product will be 0. But converse need not be true because, for example, if we can have two vectors, since two vectors which are perpendicular, their product, their dot product is also 0. So that's why it is not true. So we can either we write the reason since for any two, or we can take one example also, for any two perpendicular vectors we have A dot B is equal to 0. So they need not be 0. They need not be 0, but their dot product their dot product is 0. They need not be 0 vectors, but their dot product is 0 in this case.